Welcome back. In this lesson, we are going to keep studying algorithms. In this case, we are going to focus on algorithms that have to use conditionals. As we saw in the previous lesson, an algorithm is a finite sequence of well-defined steps. When the steps are executed in the given order, they solve a problem. The steps can be executed without knowledge of the problem that is being solved, and the steps has to be executed by a computer. I'm reminding you of the definition because it is always important to follow the definitions. So we also see this example in the previous lesson is the example that calculate the perimeter of square given the one side. This type of algorithm, we can call them linear algorithm because all the steps are executed in the given order, one after the other one. So this is not possible to solve all type of problems. Most of the problems that you are going to solve as a programmer have to be solved using a more complex algorithms. Let's see this example. Given two numbers, print the greatest one. So in this case, we have to find out from two numbers which one is the greatest one and then print it. So let's see the pseudocode. Read number 1 and number 2. Those are the two numbers that we are going to compare. It is the input of the algorithm. Then if number 1 is greater than number 2, print number 1 is the greatest one. Else, print number 2 is the greatest one. This is what is called an algorithm that uses conditionals. The conditional is represented by the if, and in this case, if a certain condition holds, then we are going to do something, which in this case is print number 1 is the greatest one. If that condition doesn't hold, then we are going to print number 2 is the greatest one. Let's see the flow diagram for this algorithm. We first have to write a start symbol. That is how we start every algorithm. Then we read both numbers, number 1 and number 2. And now we have the symbol for the conditional. And inside of that symbol, we are going to write a condition, which in this case is number 1 greater than number 2. If the result of the condition is true, we are going to print number 1. And after we print number 1, we finish with our algorithm. If the condition is false, then we print number 2 and we finish our algorithm. As you can see, we can express the conditionals in pseudocode, also in a flow diagram, but the point here is that there are algorithms that needs conditional. It doesn't matter what way you prefer to represent your algorithm, you will need to use conditionals. Let's see another example. Given an integer number, print if the number is odd or even. So let's first start with the pseudocode. First we read the number, then we use a conditional to ask if the number is even. In this case, we are going to use the operator percentage, which is also called remainder of the division. If the remainder of a division of a number divided by 2 is 0, then the number is even. That's the definition of even number. So if that condition holds, then we print the number is even. If it doesn't hold, then we print the number is odd. Let's check now the flow diagram. We use the symbol start to indicate that we are going to start the algorithm. Then we read the number. We use the symbol for the conditional, and the condition in this case is number percentage 2 equals 0. This is also read in most of the programming languages, number mod 2. So if this condition is true, then we are going to print that the number is even and we finish. If the condition is false, then we print that the number is odd and then we finish. So until now we are talking about conditions, but we didn't go too deep in what a condition is. So in programming, conditions can have only two values, true or false. Nothing that doesn't give two values, like true or false, can be called a condition in programming. This term has also a similar term that is defined in discrete mathematics. It is called proposition, and the proposition can only have two truth values, which is true or false. So conditions in programming is the same thing that propositions in discrete mathematics. So we can use any operator that returns only those two values. Let's see some of the operators that we can use to create these conditions. So first we have relational operators. These are operators that are commonly used in mathematics to compare numbers, which is less than, less or equal, greater than, greater or equal. Equal in this case have two symbols because we are comparing if two variables have the same value, or is a variable, or if a variable is equal to a certain value. We are going to use only one when we want to assign or to modify the value of a variable. So anytime we are comparing using conditionals, we need to use two equal signs. And the not equal sign, as you can see, there is an operator also for that. So you can say, for instance, if A is not equal to B. Then we also have the logic operators and, or, and not. With them, we can create what is called compound propositions in discrete mathematics. Here we can call them like conditionals with more than one operator. So if we need to use more than one operator, then we have to use logic operators to combine the conditions. So the first example is A equal B. The second example is A not equal to B. As you can see, you can express that condition in two ways. Now, if we want to, for instance, know if the value of A is between 5 and 8, here we have to use two conditions, which is A greater than 5 and A less than 8. And that's how we express it. We use here the logical operator that in this case represents the AND. And a second example is if A is if A is odd, in this case if the remainder of the division by 2 is equal to 1, and it is also greater than 10. So that's how we create conditionals using these operators and combine them using logical operators. We can also have multiple conditionals. For instance, let's say we have this problem to solve. Given a number, print whether the number is positive, negative, or 0. As you can see here, we have three possibilities. Therefore, we need to use more than one conditional. Let's see how can we solve it. So the pseudocode will be read the number. If the number is greater than 0, then we print the number is positive. Else, if the number is less than 0, then we print the number is negative. Else, print number is equal to 0. As you see in this case, we have two ifs. That's why the name multiple conditionals come from. And The last one is just a else. It doesn't ask for any other condition, because if the number is not greater than 0 and it is not less than 0, then it has to be 0. There is only one other choice. That's why in the last one we just write the else. Let's see now how can we express multiple conditionals using the flow diagram. So we read the number, then we state the condition, in this case number greater than 0. If it's true, we print that the number is positive and we finish. If it's false, then we have to check, because we have now two different choices. If it's false, the number can be 0 or it can be less than 0. So we have to use another conditional here, and this condition will be number less than 0. If the condition is true, then we print the number is positive and we finish. If the condition is false, then we print 0 and we finish. And that's how we use multiple conditionals to create algorithms. This type of algorithm that needs multiple conditionals are very, very common in programming. So remember, we are studying algorithm at the beginner level. So there are a lot more content related to algorithm, but at this level, you just need to focus here on the contents that I'm showing you here. What is an algorithm? What's the definition? What is an algorithm with conditional? And what are multiple conditionals? There is another type of algorithm that is missing before we can start using or applying those algorithms in a specific programming language, and that one we will study it in the next session. So as a summary, so far we studied what is a conditional, what are flow diagrams, how to represent conditionals using flow diagrams, how to use relational and logical operators to create conditionals, and how can we use multiple conditionals to solve certain type of problems. Thank you for watching. I will see you in the next lesson.